So let's continue talking about functions and function behaviors and move into actually looking at some examples of symbolically defined functions and how we work with them. So here's an example of a symbolically defined function. It's also defined in words. Consider the formula a equals 1000 times 1.075 to the exponent t, which gives the dollar amount A in an investment account as a function of T, the elapsed time in years after the account was opened. So we have some questions about this function, if it is a function. But let's talk about, before we answer any questions, let's talk about what this function does and what all these words mean, okay? So when we say exponent t, that's a very particular kind of function behavior. We're in fact going to have an entire unit where we work with exponential functions, but this is an example of an exponential function. This is our first example. What makes it an exponential is when you have anything of this form, a times b to the t power, or x power. Okay, so this is the exponent. All right, and what that means mathematically is when you have a number raised to a power like this, then in this case that's 1.075. So if I have, this is raised to say the third power, then we would have, I'll just write it over here, 1.075 to the third is equal to 1.075 times 1.075 times 1.075. So 3 times. That's the basic idea. Okay. Now what does this function do? It gives you the dollar amount in A of an investment account as a function of elapsed time. So elapsed time means that the clock is reset. In fact, let me make a note of that. What I mean by the clock is reset is that time starts at it's basically like a stopwatch time. So we start at time 0 and then we go forward from there. This would be in contrast to calendar time, in which case you'd actually put in like the clock time. So it was like 3:30 or the year was 1995. We would actually input those values, but not in this case. In elapsed time, we reset the clock to 0. Okay, so is A a function of t? Well, the easiest way to see that this is a function is to graph it and see that it passes the vertical line test. But if you don't want to look at the graph, we can also think about what this function does. So for any given input, any number that you put in for t, we can input that into the calculator and then multiply that result by 1,000 because 1,000 is the other part of this function. We'll only give a single number. So this will always give you an output. So it is a function. Okay, let's talk about graphing the function on the interval 0 to 20 and kind of what it looks like. So let me pull up the calculator and let's do some work with this. So first go to y equals, actually let's check and make sure that my stat plot is turned off. It is, so that's good. All right, I'm going to go to y equals, and I'm going to enter the function. When you have an exponent, you use this button right here. And this is our variable button. We don't have we don't use t specifically, we'll just use x, okay? So there's our function. Now I want to graph this, but I want to graph it on a particular window. So the problem asked for the interval 10 to 20. I'm sorry, 0 to 20. So I will go to my window. I'm going to change that to 0, that to 20. And then for my for my Y values, I don't exactly know what those are going to be. So what I'm going to do is go to Zoom and scroll down to Zoom Fit and select Zoom Fit. And we should get a graph here in a moment. There it is. So how would you describe this trend? Well, it's increasing, but it also curves, and it curves upwards, so at an increasing rate. So this is increasing and concave up. Okay. All right, so there's a little bit of basic work with a symbolically defined function. Let's do some more stuff with this function. Here we got a sequence of questions. And let's talk about answering these. This is also going to involve learning some new calculator techniques, which are very important. So let's dive into this. What is the account's balance 5 years after it was opened? So this is essentially asking you to evaluate the function when the input is 5. And the best way to do this, and actually there's two good ways to do this, but to me the easiest way to do this in the calculator is as follows. You just go back to your regular computation screen, and we're going to use the fact that we've already named the function here as y1. And what I want to do is basically call it up and then evaluate it. So the way you call up a function is you go to vars and then arrow to yvars, select function y1. And now I've called up function y1. And then I do parentheses, 5, close parentheses, and that will evaluate the function at the input 5. So there's the output, 1435. So let's write that down. I have to pull it back up here. 63 cents approximately. Okay. So the keystrokes that I just used, those are the two main ones. Hopefully after that you'll remember what the following keys were, but I'll be doing this many times, so you'll see lots of other examples of the vars, yvars calculator method for evaluating a function. Okay, let's look at questions B and C. Question B says, how long will it take for the balance to reach $2,500? So this is a different type of question because in this case, the $2,500, that's an output. And I want to know the input. It's a bit hard to read, but the point is this. We are given an output, and we're looking for the input, the time. And that means that we have to approach this problem slightly differently. So we know that whatever the time is, the output is 2,500. So really what we have is this. We have 2,500 equals 1,000 times 1.075 to the t. Now, if this was a standard pre-calculus class, we would approach this by solving this equation for t, which is fine, and you can certainly do that. But what I want to do is talk about how to solve this problem graphically using the TI-83 or 84. The basic idea is this. If I graph this function, we know already that it looks something like that, right? And there's 0 and there's 20. Now, 2500 is an output, and so it's going to be up here somewhere. And what I am trying to find is the intersection right there of this horizontal line, which represents the height line of 2500, and the function itself. Now, I don't let me mislead you. This 20 down here. Actually, let me just erase that. The point is that we don't know that. We don't know that t value. And so we have to find it. So we're going to use the calc, actually it's just called calc intersect on your calculator to find this intersection point. Calc intersect. Okay, now I'm going to show you a slide that has detailed instructions for all of this. Okay, and as we read through this slide, we'll actually do this together. Okay, so how do we do calc intersect? First of all, we've got the function entered, so that's good. Now, the next thing is we want to know when it intersects the value 2500. So notice what I'm doing here is I'm entering 2500 in as y2. That means that this is going to give me a horizontal line of height 2500. Okay. Now, the only other issue here is that I don't exactly know where to look. Like, for example, I could graph this, and I might see a graph that didn't actually capture the intersection, because the intersection only happens in one spot, and I don't really know where to look. So how could we figure that out? Well, one way to do this is to go to the table, and that's what's happening here in this slide. So as it says, we can press. This is actually doing the table in increments of 5. Let me just go to the table as it stands right now. So you see right here in yellow, I've got second table. I'm just going to go straight to that and look at the table. And what it's doing here is it's compiling at these inputs. This is the function value. This third column over here, y2, that's 2500 because it doesn't change. No matter what input you put in, you always get 2500 out for this horizontal line. But for y1, it does change. So as we scroll down through these inputs, you see that y1 is getting bigger and approaching 2500. And in fact, right there between 12 and 13, we exceeded it. So what does this tell me? This is telling me what my domain should be in order to see the intersection. So if I make sure that I have 12 to 13 in my domain, and then I do zoom fit, then I will see the intersection. So let's go to Window, change this. Actually, 0 to 20 is fine because that would include 12 to 13. But well, let's just leave it at that, and then we'll do zoom fit. And let's wait for this to graph, and we should see the intersection. And there it is. Okay, so the next step is to actually calculate the value of this intersection, and that uses the calc intersect procedure. So I'm going to pause the video and then we'll come back and we'll actually show how the intersection procedure works.